The world we are accustomed to seeing every day is, in reality, deeply illusory. A person walking past a blooming lilac bush or an apple orchard notices only bright petals, inhales a sweet aroma, and feels a light summer breeze. But if we could, for just a second, borrow the compound eyes of a tiny creature weighing only about 120 milligrams, our familiar reality would instantly shatter into thousands of multicolored fragments. Flowers that appear monochromatic to us, yellow, pink, or white, would suddenly burst into neon patterns, revealing hidden landing strips that glow in the ultraviolet spectrum, guiding the way to the most valuable nectar. Evolution forged this secret alliance, invisible to us millions of years ago. The flower sends a signal, and the bee obediently carries the pollen. Have you ever wondered if bees are among the most intelligent and complex creatures on the planet? We are used to perceiving them as a mere element of the summer landscape, buzzing annoyingly in our ears, or as living factories, producing a sweet treat for our tea. However, behind this tiny body, which can easily fit on your thumbnail, lies a mind so profound and ancient that human civilization seems like a brief moment in Earth's history by comparison. While the dinosaurs were born, dominated the planet, and slowly faded into oblivion, these winged architects were already flying from flower to flower, creating the very biosphere in which humans were later destined to appear. The oldest fossilized bee, frozen in a transparent drop of amber resin, is a venerable 100 million years old. 100 million years of continuous labor, of honing navigation skills, mathematical calculations, and social interaction. Bees are amazing winged insects, renowned for their fantastic passion for nectar and pollen, as well as their production of honey. But this is only the tip of the iceberg. There are about 20,000 species of bees in the world. Most of us, when encountering them at a country house or in a field, know only a single species, the honeybee. But what happens to the other 19,999 species? They live their quiet, solitary, and practically invisible lives right beside us. Part 1. The diversity of a hidden world, from giants to grains of sand. Contrary to stereotypes, the vast majority of bee species lead a solitary lifestyle. They do not build huge, buzzing hives, do not obey a strict hierarchy, and do not collect tons of honey. These invisible laborers dig tiny burrows in the damp earth, set up nests inside dry plant stems, or find shelter in deep rock crevices and abandoned tunnels left by wood-boring beetles. They perform a colossal amount of work, pollinating wild plants while remaining in the shadow of their famous domesticated relatives. However, some species, including honeybees and bumblebees, took a different evolutionary path and created highly complex social colonies. These colonies represent the pinnacle of biological cooperation. They function as unified structures consisting of 3 castes: a single queen, who is the heart and reproductive center of the entire family, tens of thousands of female worker bees, sterile laborers upon whose shoulders rests absolutely every aspect of the community's life, and several hundred drones, males whose role is strictly limited in time and space. The variety of shapes and sizes in this vast family staggers the imagination. At one extreme is the legendary Wallace's giant bee, recently rediscovered by researchers in the dense Indonesian jungles. This fearsome beauty reaches 4 centimeters in length, possesses impressive jaws resembling those of a stag beetle, and emits a low, rumbling drone in flight. At the other extreme are the worker individuals of certain tiny stingless bees whose size barely exceeds that of a grain of rice. They gather pollen from the smallest flowers, which are completely inaccessible to larger insects. Bees are incredibly adaptable in ecological terms. They are found on every continent of our planet, with the sole exception of icebound Antarctica. They can be found in the scorching deserts of Africa, the endless steppes of Eurasia, the dense rainforests of the Amazon, and the cool coniferous forests of Scandinavia. The main and only condition for their existence is the presence of flowering plants pollinated by insects. The honeybee, which became man's primary companion, was originally native to the warm regions of Africa and Eurasia. However, over thousands of years of active human history, thanks to the development of beekeeping and commercial apiculture, It has spread across the entire globe, adapting to a wide variety of climatic conditions. Bees play a vital, pivotal role in pollinating many of the plants we depend on directly and indirectly for our food. Orchards, vegetable plantations, and berry fields exist in their familiar abundance, only thanks to the untiring work of these winged creatures. Yet, their numbers and species diversity have been steadily declining for several decades worldwide. This is a silent catastrophe unfolding right before our eyes. In the United Kingdom, for instance, according to long-term ecological monitoring, bees have completely vanished from a quarter of the places where they could easily be found just 40 years ago. Meadows are emptying, and the familiar summer hum is being replaced by an ominous silence. Part 2. The Superorganism and the Anatomy of a Miracle. To understand just how intelligent bees are, one must first peer inside their home. A single hive is not just a mechanical gathering of thousands of individual insects. Biologists use the term superorganism to describe a bee family. This means that the hive functions as a single living entity, where each individual performs the function of a specialized cell or organ. No bee can survive alone for more than a couple of days. It is genetically and mentally woven into the common network. In a typical healthy hive at the height of summer, there are between 40 and 80,000 individuals, and in particularly favorable seasons, this number can reach 100,000. At the head of this vast metropolis stands a single queen. She is a true machine of fertility, capable of laying up to 2,000 eggs a day during the season of high activity. Her lifespan can last up to 5 years, an absolute record of longevity in the hive, considering that an ordinary worker bee during the summer period of grueling labor lives for only about 6 weeks. The males, or drones, represent a very specific caste. They are larger than worker bees, have huge eyes that help them track the queen in the air, but they completely lack a stinger. They do not work, do not gather nectar, do not secrete wax, and are incapable of defending their nest. Their sole task in life is to fertilize a young queen during her nuptial flight. All season long, they live on everything provided for them, consuming the shared honey reserves. But as soon as autumn arrives, the warmth leaves and the flow of nectar dries up. The worker bees ruthlessly, but pragmatically, drive the drones out into the cold, where they inevitably perish from hunger and freezing. There is no room for sentimentality in a superorganism. It is a matter of strict economic calculation. There is no reason to feed extra mouths during the harsh winter period. All the other inhabitants of the hive are worker bees, biologically being females with underdeveloped ovaries. They are the ones who perform a colossal spectrum of tasks. Life inside the hive is subject to a strict order, and throughout her short life, a worker bee successively changes several professions that depend directly on her age. It all begins with the first days of life. A young bee aged 1 to 3 days works exclusively as a cleaner. Her main task during this period is to thoroughly clean the cells and remove all accumulated debris from the nest. Then, on the 4th day, her body reorganizes. Up until the 12th day of life, the bee becomes a nurse. Special glands begin to function actively in her body, and she now feeds the growing larvae with royal jelly and bee bread. The next stage occurs at the age of 13 to 18 days, when the bee turns into a builder. During this time, she begins to intensively secrete wax plates. From this material, together with her sisters, she erects new honeycomb structures and repairs damaged areas of the home. Around the 19th to the 21st day, the bee transitions to security duty and becomes a guard. She stands watch at the entrance, defending the colony from enemies and carefully checking the chemical markers of everyone attempting to gain entry. And finally, at the age of 22 to 42 days, the final, most dangerous, and responsible phase arrives. The bee becomes a forager. As a field bee, she sets off on long flights to gather nectar, pollen, propolis, and water for the entire colony. This incredibly complex social ladder functions without any orders from above. The queen is not a director or a general. She does not hand out commands. Her role in management is purely chemical. She secretes special pheromones, the so-called queen substance, which spread through the hive from bee to bee, signaling that the queen is alive, healthy, and that the colony is safe. If the queen dies, the The disappearance of this chemical marker within just a few hours triggers panic among the bees, forcing them to urgently restructure their activities to rear a new ruler. The anatomical structure of a worker bee is a masterpiece of natural engineering. Her body is divided into three distinct sections: the head, thorax, and abdomen. On the head are complex compound eyes and three simple eyes, as well as the main sensory organs, the antennae. These antennae continuously scan the environment, picking up the slightest changes in temperature, humidity, carbon dioxide concentration, and, of course, odors. On the bee's hind legs are the famous pollen baskets, special smooth depressions surrounded by rows of stiff, curved hairs. Brushing the trapped grains of pollen from her fluffy body, the bee moistens them with a drop of nectar and carefully presses them into these baskets, forming dense, bright yellow-orange balls called pollen pellets. It is with this cargo that she returns triumphantly home. The bee's defensive weapon, her stinger, has a barbed shape resembling a fishhook. It is important to note that this tool is possessed only by females, meaning worker bees and the queen. When a worker bee drives her stinger into the elastic skin of a mammal, the barbs hold it firmly inside. The bee attempts to fly away, but the stinger is torn from her body along with part of her internal organs and the venom gland, inflicting a fatal injury on the insect. The bee sacrifices her life to defend the colony, and this step is always a last forced resort. The queen, on the other hand, has a completely smooth stinger, without barbs. She can use it multiple times and remain unharmed. However, she applies it exclusively in rare duels with her direct rivals, other young queens in the struggle for the throne. Part 3. How intelligent are bees? The shattering of anthropocentrism. For a long time, the dominant view in the scientific community was that insects are primitive living automatons driven solely by rigid, innate instincts. It was believed that a tiny brain, weighing only about 1 milligram, which is smaller than a printed comma, was simply incapable of complex cognitive processes. However, modern behavioral experiments have forced scientists to radically revise their views. Bees possess an astonishing, flexible, and abstract level of intelligence. They are capable of counting, solving highly complex logical puzzles, learning from one another, and even consciously using tools. Scientists conducted an elegant experiment designed to test the counting abilities of bees. They trained a group of bees to fly to a feeder with sweet syrup located at a distance of 300 meters from the hive. On the path to this target, the researchers placed 3 completely identical large yellow cones at equal distances from each other. The bees quickly memorized the route and began landing flawlessly at the coveted treat. Then, the scientists decided to change the rules of the game. They removed 2 of the landmarks, leaving only a single cone in its original position. The result was astonishing. The bees, having reached this single cone, flew much farther, vainly attempting to find the second and third reference points. When the number of cones on the same stretch of path was increased by placing them closer together, the bees landed much earlier, having barely counted 3 landmarks. This proves that they did not simply estimate the distance traveled by optical flow or wing fatigue, but literally counted the objects along the way, using them as numerical markers to make a landing decision. Furthermore, accompanying tests showed that bees are capable of understanding the concept of zero, an abstract notion of the absence of objects, which places their cognitive abilities on par with certain bird species and higher primates. In another revolutionary study, British scientists created a special puzzle box for bees. Access to a sweet sugar solution inside it was blocked by a transparent round lid. It could be opened in only one of 2 ways. The first option was to press a special red button, which caused the lid to rotate clockwise. The second option was to pull a blue plastic tab, turning the mechanism in the opposite direction. First, the researchers took several demonstrator bees and, through long training, taught them to open the box in a specific way, for instance, only by pressing the red button. When these trained bees were released into a shared enclosure with their nestmates, something incredible happened. The rest of the colony members, who had never seen this puzzle before, watched the actions of the successful foragers intently. Within a short time, ordinary bees began opening the box independently and flawlessly, using precisely the method they had observed from the demonstrator. If the demonstrator pulled the blue tab, the whole group adopted that exact technique. This discovery demonstrated what was previously considered the exclusive province of humans and certain mammals: social learning and the ability to form a local culture within an individual community. It was long believed that using external objects as tools was available only to creatures with a highly developed cerebral cortex. In laboratory settings, bees had already been successfully taught to pull a string to reach a treat or roll a small ball into the center of a circle for a reward. But a true sensation occurred in the year 2020 when scientists recorded the use of tools by bees in an absolutely wild natural habitat. In Southeast Asia, local Asian honeybees face a deadly threat from giant predatory hornets. These massive killers are capable of completely wiping out an entire bee colony in just a few hours, plundering the hive and feeding the larvae to their own offspring. To defend their home, the bees came up with a unique defensive strategy. They began gathering the fresh feces of domestic animals, cows, pigs, chickens, and carefully, piece by piece, smearing them around the narrow entrance to their nest. The smell of the excrement turns out to be so sharp and unpleasant for the hornets that they lose their orientation, cannot detect the precise chemical markers of the beehive, and refuse to attack such an unappealing target. The bees purposefully find, transport, and apply a foreign substance to alter the properties of the environment for defensive purposes. This is a classic, indisputable use of tools recorded in the wild. Part 4. The language of dance and odors, symbolic communication. One of the brightest manifestations of the bees' incredibly high intelligence is their method of communication. They are practically the only creatures on Earth, besides humans, to have developed their own symbolic language to transmit information about objects located at a vast distance. In the year 1946, Austrian biologist Karl von Frisch made a discovery that initially shocked the scientific world and seemed like science fiction. Bees talk to each other through a structured dance. For this fundamental discovery, von Frisch was awarded the Nobel Prize in 1973. Bees communicate in two main ways: through expressive body movements and through subtle aromatic codes, namely pheromones. When a worker scout bee returns to the hive after a successful search for a nectar-rich field, she does not simply drop her catch. She rushes onto the vertical wax honeycombs, where she is immediately surrounded by other bees, and begins to perform her famous waggle dance. The insect describes a distinct figure-8 shape on the flat surface of the comb. The movement is divided into two phases: semicircular return loops and a straight line through the center. When the bee steps onto this straight central portion, she begins to vibrate her abdomen intensely from side to side, performing waggles, and flaps her wings rapidly. Every movement in this dance is strictly coded mathematically. The length of the straight section and the duration of the waggling indicate the exact distance to the target. Each second of continuous abdominal waggling means that the flight must extend roughly another 100 meters farther. The angle of the straight line relative to the strict vertical of the combs encodes the direction of the flight relative to the current position of the sun in the sky. If the bee runs straight up the combs, it means that the flight path is directly toward the sun. If the angle is deflected 40 degrees to the right of the vertical, it means that one must steer a course 40 degrees to the right of the sun. The intensity and duration of the entire dance vividly demonstrate the quality and richness of the food source found. The sweeter the nectar and the more flowers in the meadow, the more energetically, longer, and enthusiastically the bee performs her movements, drawing more and more onlookers into the process. In addition to the figure-8 waggle dance, bees have other choreographic elements in their repertoire. For example, if a rich food source is located very close to home, within 50 meters, the bee performs a simplified round dance. She runs in a circle, abruptly changing direction to the left and then to the right, signaling that the food is very close and they only need to fly outside and search for it by smell. If too much nectar is pouring into the hive and the receiver bees do not have time to process it, the foragers perform a special tremble dance or shaking. This is a signal for young bees inside the nest to drop their cleaning duties and urgently switch to processing the brought raw material. During the dance, the bee also actively releases a highly complex cocktail of pheromones. The surrounding bees closely follow the movements of the dancer in the darkness of the hive, touch her body with their sensitive antennae, reading the odor molecules of the specific flower, and, having received the full coordinates, set off on their way. Part 5. Navigation: The Secrets of a Sesame Seed. Bees regularly make long-distance flights of 3 to 5 kilometers from their hive. They twist between trees, cross hills, rivers, and highways to gather nectar, and then return by the shortest, direct route back to their home entrance. And they do all this while possessing a brain the size of an ordinary sesame seed. How does this perfect navigation system work? The main guide for a bee in the sky is the sun. But what if the sky is completely overcast with heavy storm clouds or covered in thick fog? A human in such conditions loses visual reference points, but not a bee. Her complex compound eyes possess the unique ability to perceive polarized light. Light waves passing through the Earth's atmosphere scatter in a specific way, creating a clear grid of polar lines across the sky that remains stable even behind a thick layer of clouds. The bee literally sees the exact position of the hidden sun through any cloud. The position of the sun in the sky is not static. It shifts continuously from east to west throughout the day. Bees possess phenomenal built-in biological clocks. When a scout dances in the dark hive, telling of a food source found in the morning, she automatically makes an adjustment for how much time has passed since her flight. She indicates to her sisters the flight trajectory relative to the current up to the minute position of the sun, rather than the position it was in when she collected the nectar. The insect's brain continuously recalculates the trigonometric corrections of the celestial body's movement. If the sun has completely set, or the bee has to navigate deep crevices, a third navigation system comes into play. Physiological studies have shown that a honeybee's abdomen contains microscopic granules of a magnetic mineral, magnetite. This built-in structure is connected to the nervous system and works like a highly sensitive internal compass that reacts to the Earth's magnetic field. The bee is capable of memorizing the geomagnetic map of her locality and using it as a backup guidance system to reach her target. Part 6. The Alchemy of Nectar: How Eternity is Born. The process of making honey is not just a mechanical collection of sweet water from flowers. It is a highly complex biochemical production that requires colossal energetic and physical investments from thousands of living beings. Nectar secreted by flowers initially consists of nearly 80% water. Sugars and a small amount of minerals are dissolved in it. To turn this perishable liquid into honey, bees must perform a true miracle of transformation. The forager bee lowers her long, flexible proboscis deep into the flower and sucks up the nectar, placing it into a special honey stomach. This is a unique internal reservoir separated from her own digestive stomach by a special valve. The bee does not digest this nectar, she merely transports it. The capacity of the honey stomach is about 40 milligrams. To fill it completely, the little worker has to fly around and minutely search anywhere from 100 to 1,500 flowers in a single foraging trip. Already during the return flight, the magic begins inside the honey stomach. Special glands of the bee secrete enzymes, primarily invertase, which launches the process of breaking down the complex sucrose of the nectar into simple sugars, glucose and fructose. Arriving at the hive, the forager transfers the drop of nectar to a receiver bee through a process called trophallaxis, meaning mouth to mouth. The receiver bee draws the liquid into her own honey stomach, enriches it with new enzymes, and then passes it to the next bee down the line. This process is repeated multiple times. Then, the partially processed nectar is deposited in drops along the walls of the wax cells. To remove excess moisture, hundreds of bees gather together and begin to fan their wings continuously and synchronously, performing up to 230 beats per second. They create a powerful, warm, regulated airflow, a true forced ventilation system for the hive. When the water content in the substance drops below a critical 18%, the honey is considered ripe. The bees tightly and hermetically seal the cell with a thin, airtight wax lid. The scale of this labor is staggering. To produce just 1 teaspoon of honey, a bee or a group of bees must fly a total distance of about 120,000 kilometers. This distance is equivalent to 3 full trips around the Earth along the equator line. In doing so, the insects must visit approximately 2 million flowers. Over her entire short 6-week life, a single worker bee is capable of producing only about half a teaspoon of honey. When you put a spoonful of honey into your morning tea, you are consuming the result of the entire lifespans of 12 tiny creatures. Honey is the only food product on the planet that never spoils. During excavations of the tombs of the Egyptian pharaohs, archaeologists have repeatedly found sealed clay vessels containing honey that was placed there more than 3,000 years ago. After chemical analyses were conducted, it turned out that this ancient honey completely retained its properties and remained absolutely edible. The secret of this immortality lies in a unique combination of three physical and chemical factors. First is the extremely low moisture content, which is less than 18%. Honey literally draws moisture out of any living cells, and entering such an environment, bacteria or fungi instantly perish from dehydration. Second is the high acidity of the medium. An acidic environment is highly hostile to the vast majority of pathogenic microorganisms. And third is the release of hydrogen peroxide. The enzyme glucose oxidase added by the bees, upon slow contact with residual moisture, continuously generates microdoses of peroxide, destroying any attempts by microbes to multiply inside the comb. This is exactly why honey served as humanity's primary natural antiseptic for millennia. Part 7. A full pharmacy behind a wax wall. In addition to honey, the bee superorganism produces a whole spectrum of unique biologically active substances, each of which is a masterpiece of biochemistry. Beeswax is the primary building material of the hive. Bees do not gather it from the outside. They secrete it themselves, using special wax glands located on the abdomen. This is an incredibly resource-intensive process. To synthesize and secrete just 1 kilogram of pure wax, bees must consume and process inside their bodies about 8 kilograms of ripe honey. Humans have used wax throughout their history, from making the first candles to creating cosmetic ointments. Another important product is propolis, or bee glue. This is a resinous, bitter substance that bees collect from the sticky buds of trees and mix with their own enzymes. In the hive, propolis plays the role of an ideal insulation material and a powerful chemical shield. They use it to seal the slightest cracks in the walls, regulate the width of the entrance, and disinfect the inner surfaces of the cells before the queen lays eggs there. If a large pest, for instance, a field mouse, breaks into the hive, the bees sting it to death. But they are unable to carry the heavy carcass outside. To prevent the decaying corpse from becoming a source of a fatal infection for the entire colony, the bees completely entomb it, covering it with a thick layer of propolis. A perfect natural mummification takes place. The carcass can lie for years without releasing a single bacterium or odor. It is also worth mentioning royal jelly. This is a special, highly nutritious substance secreted by the glands of young nurse bees. They feed absolutely all larvae in the hive with it during the first 3 days of their lives. But the larva destined to become the future queen receives this jelly continuously, in huge quantities, throughout her entire development. This is one of the most amazing examples of epigenetics in nature. Genetically, the larva of the future queen and the larva of an ordinary worker bee are absolutely identical. They share the exact same set of DNA. But thanks to the diet of royal jelly, a highly complex hormonal cascade is triggered. As a result, a creature grows that is twice the size of a worker bee, lives 40 times longer, and is capable of reproducing millions of offspring. Finally, bee venom, or apitoxin, represents a highly complex chemical cocktail based on the protein melittin. Modern medical research shows that melittin is capable of precisely destroying the protective envelopes of certain aggressive cancer cells and viruses, opening new horizons in pharmacology. Part 8. The Great Pollination: Why the World Will Collapse Without Bees. Honey, wax, propolis, all these are mere crumbs compared to the main, fundamental mission of bees on our planet. This mission is pollination. About 80% of all flowering plants on Earth are physically incapable of setting fruit and producing seeds without the help of insect pollinators. And the lion's share of this colossal work is performed precisely by bees. Roughly 1/3 of all the food consumed daily by humanity exists solely thanks to bee pollination. Among the crops that depend entirely on bees are a huge number of our favorite foods. There are fruits, apples, pears, cherries, peaches, apricots, and plums. There are vegetables and cucurbits. cucumbers, zucchini, pumpkins, onions, and watermelons. There are berries, strawberries, raspberries, blueberries, and blackberries. This category also includes nuts, such as almonds, which depend on bees by 90%, as well as coffee and cacao, which gives us chocolate. At the same time, grain crops, such as wheat, rice, and corn, as well as potatoes, are pollinated by the movement of air masses, meaning the wind, and do not depend on bees. And this is precisely what gave rise to the famous quote, often attributed to Albert Einstein. He allegedly said that if bees disappear from the face of the earth, humanity would survive for no more than 4 years, because there would be no plants, then no animals, and eventually, no humans. Historians dispute the authorship of the great physicist, asserting that he never said this, but the essence of the matter remains unchanged. Modern ecological scientists sign their names under every word of this statement. Without bees, the planet's food chain would undergo a total, cascading collapse in a matter of years. If bees vanish, humanity, of course, will not go extinct instantly. We could theoretically survive by eating nothing but bread, rice, and porridge. But all bright colors, flavors, and vitamins would vanish from our lives forever. A global crisis of vitamin deficiency would begin. Furthermore, recent large-scale medical studies have revealed frightening statistics. The current global decline in the number of insect pollinators already leads to the premature death of about 500,000 people annually worldwide due to a deficit of healthy plant food. But the catastrophe would extend far beyond human plates. In the wild, the disappearance of bees would lead to the extinction of thousands of species of wild-flowering plants, following which the populations of birds and other animals would collapse. The ecosystem would begin to fold in on itself like a house of cards. Part 9. Colony collapse disorder. Why are they leaving? Bees are in a state of profound global decline. Since the early 2000s, beekeepers and scientists around the world have begun to record a frightening, mystical phenomenon, officially named colony collapse disorder. The scenario always unfolds in the exact same way. Worker bees at some point simply fly out of the hive and never return. At the same time, there are no dead bodies around the hive. Inside remains the queen, honey reserves, and a small amount of helpless brood. The family simply dissolves into space. In the United States alone, between 2006 and 2008, this disorder destroyed more than 30% of all commercial bee colonies. There are several causes for this ecological disaster, and they strike the superorganism simultaneously. First is chemical poisoning by modern insecticides, neonicotinoids, which agricultural corporations use to mass treat fields. In small doses, these substances penetrate nectar and slowly destroy the insect's central nervous system. The bee's perfect navigation system breaks down completely, and her memory is wiped. Flying out for nectar, she simply forgets where her home is, loses her orientation, and perishes somewhere in the field. Second is a microscopic parasitic mite, Varroa destructor, accidentally introduced from Asia. It attaches itself to the bee's body and literally sucks the life out of her, critically weakening her immunity. Third is the creation of monocultural deserts in agriculture, where endless fields of pure wheat or corn deprive bees of a variety of herbs, leaving them with nothing to eat. When bees completely disappear from a region, humans have to take over their work. This is a reality that has already occurred in Sichuan province in China. There, due to the uncontrolled application of the strongest pesticides, bees died out completely. As a result, local farmers were forced to pollinate vast apple and pear orchards by hand. People climbed ladders with small jars of dry pollen and bird feathers, methodically touching each open flower on a tree. This is an extraordinarily heavy, inefficient, and incredibly expensive labor, visually proving that replacing the natural forces of nature with human hands is impossible. Part 10. 5. Major myths. About bees, debunking stereotypes. A huge number of deep misconceptions have accumulated around bee life over the centuries. It is time to dismantle the most popular ones from the standpoint of rigorous academic science. The first myth states that bees are too heavy and, according to the laws of physics, should not be able to fly. This myth originates from a 1934 French book, titled The Flight of Insects. The author applied standard aerodynamic equations used back then for calculating fixed-wing aircraft to the flight of a bee, and the formulas showed that the bee's tiny wings could not hold its body in the air. Of course, the researcher was grossly mistaken, transferring the principles of aviation to living micronature. A bee does not glide through the air like a sailplane. Her wings make complex, circular rotational movements at a speed of about 230 beats per second, creating miniature air vortexes that push her upward. The second myth claims that absolutely all bees can sting painfully. This is not true. To begin with, male bees, drones, are physiologically devoid of this capability. They have no stinger at all. A biological stinger is a deeply modified ovipositor, which can only be present in the anatomy of females. Furthermore, there is a huge family of so-called stingless bees in the world, numbering about 550 species. Their stinger has reduced during evolution to such tiny dimensions that they are physically incapable of piercing human skin. The third myth declares that every bee always perishes after it stings. Out of all the bee species on the planet capable of stinging, a tragic death after a sting is destined exclusively for the honeybee, and only when attacking creatures with elastic skin, meaning mammals and humans. The barbs on her stinger get stuck firmly in the skin, and when the bee tries to fly away, her abdomen tears apart. However, if this same bee stings another insect, she easily pierces its hard, chitinous shell and pulls the stinger back out without any problems, remaining alive. The fourth myth assures that all bee species without exception produce sweet honey. Most bee species on Earth have absolutely nothing to do with the production of honey. Out of 20,000 species known to science, only 8 true honeybee species are capable of harvesting and storing honey in commercial volumes. A few hundred other species of wild social bees, such as bumblebees, also know how to produce a semblance of honey, but in extremely small quantities, exclusively for themselves. All the other thousands of solitary bee species do not make honey at all. The fifth myth tells that all bees in a hive are incredibly industrious from dawn to dusk. This myth is only partially true, exclusively regarding the caste of worker bees and the queen. But the same cannot be said about the male drones. Their entire day consists of lazy rest on warm honeycombs, consuming ready honey gathered by their sisters, and occasional flights outside in anticipation of a young queen. They perform no useful economic activity inside the hive. Part 11. Swarm Democracy and Technologies of the Future. What can humans learn from a bee? It turns out, a lot. Bees make critical collective decisions using a method that modern sociologists and mathematicians call swarm democracy. When a bee family grows too large in the spring, the old queen takes about half of the flying workforce with her and leaves the hive forever. This giant, buzzing cloud temporarily settles as a dense, living cluster on a branch of a nearby tree. At this moment, they are occupied with a vital task, searching for a new, permanent dwelling. To do this, several hundred experienced scout bees fly out from the swarm. They disperse in all directions, inspecting the surroundings in detail. Returning back to the hanging swarm, each scout begins to perform a dance right on the living surface of the bee cluster, advertising her option. If the hollow she found is dry and safe, her dance will be incredibly passionate and long. If the place is mediocre, her movements will be sluggish. Other scouts closely observe the dances of their colleagues, fly out to the specified coordinates, personally inspect the proposed options, and, if they agree with the assessment, join the dance. A pure horizontal discussion takes place, where no one has a veto right. Gradually, an increasing number of scouts begin to dance for a single, objectively best option. As soon as the number of bees dancing for one location reaches a quorum, the entire multi-thousand swarm simultaneously lifts off and flies to its new home. This unique ability has inspired modern engineers. Today, swarm intelligence algorithms built on mathematical models of scout bee behavior are actively applied in logistics to optimize complex cargo transportation routes, in computer networks to redistribute internet traffic, and in robotics. Scientists are creating entire swarms of tiny microdrones that learn to coordinate their actions in the air, communicate without a single central command unit, and perform joint rescue or agricultural operations. But for now, All these expensive technological contrivances are merely a pale, clumsy copy of that perfect system which nature polished over 100 million years. Part 12. Bees in the Mirror of History. Human civilization is tightly woven into the history of the bee superorganism. Rock paintings in Spain, created more than 8,000 years ago, vividly depict a person climbing into a wild rock crevice, surrounded by a swarm of insects, to gather coveted wild honeycombs. In ancient Egypt, the bee was a sacred symbol. Its stylized image was an integral part of the official title of the pharaoh, personifying devotion and industriousness. The Egyptians were the first in history to transition to commercial beekeeping. They manufactured hives from baked clay tubes and loaded them onto huge wooden barges that cruised up and down the Nile River, following the seasonal blooming cycles of coastal plants. In ancient Greece, fragrant honey was considered the exclusive food of the Olympian gods, and the father of medicine, Hippocrates, dedicated entire treatises to treating deep wounds with honey. In medieval Europe, long before the appearance of sugar, honey remained the only available sweetener, and beekeeping was a crucial part of monastic economies, since pure wax went entirely toward making church candles. Even the great Emperor Napoleon Bonaparte, during his coronation, consciously rejected the traditional lilies, choosing a golden bee as his personal coat of arms and state symbol, which personified the ideal qualities of his new empire: iron discipline and the colossal collective power of a superorganism. Conclusion: how to save those who save us. We are used to not noticing the bee in our daily rush. We often wave it away irritably at a picnic, fear its painful sting, casually spread honey on our morning toast, and give absolutely no thought to the titanic, incredible labor that stands behind every single gram. But the dry truth is that every fruit you hold in your hands, every wild berry, every bright flower in the meadow, and every tree in a green park exists in this world solely thanks to the work of this tiny creature. A creature weighing no more than a paperclip and with a brain smaller than a poppy seed. Without it, a third of our food system would turn to dust. These are not the sentimental sighs of nature conservationists. This is the sober, pragmatic logic of our species' survival on planet Earth. We need bees literally. And today, when they are dying en masse from our chemicals, monocultures, and climate changes, the time has come for humans to finally pay attention to them and repay this 100-million-year debt. What can each of us do right now, at our own everyday level, to help bees survive? You can plant flowers. It doesn't matter where, on a high-rise balcony, in a flower bed in the yard, or on a garden plot. Sow lavender, sage, marigolds, or ordinary clover, creating a small oasis for insects amid the asphalt. Try not to mow dandelions prematurely, because the bright yellow heads on spring lawns are the very first, vital source of fresh pollen and nectar for bees that have just woken up after a long and grueling winter. It is also worth giving up pesticides and harsh chemicals in your garden, replacing aggressive insecticides with organic plant protection methods. And finally, if you find a dense cluster of bees on the wall of your country house or on a tree branch, do not panic and do not reach for a can of poison. Find the contacts of a local beekeeper and call him. He will gladly, carefully, and gently take this swarm to a new, clean, wooden hive, saving the lives of thousands of unique, highly intelligent creatures. The bee has been quietly and silently doing its great work for 100 million years. It does not demand rewards, monuments, or recognition from us. It needs only one thing: for us to simply let it keep flying.